Alright everybody, today's lesson is on equations in two variables. So what we started talking about yesterday when we were dealing with functions is that we're going to have two variables now. So something like y equals x minus 3, okay, where there's two variables in our equation. And one thing that we said was what we're doing is finding pairings. We're finding partners that go together to answer this problem. For example, if I said that x equals 0, well, what we did was we went ahead and put this 0 into the problem to get y equals 0 minus 3, and then we would find a specific y that went with it. Y would be negative 3. Those two answers together, x being 0 and y being negative 3, that ordered pair is a solution to this equation. Because if I know that the 0 is my x and the negative 3 is my y coordinate, well, I can plug those two things in place of y, and it becomes an answer to the problem, because negative 3 does equal 0 minus 3 because it becomes equal to each other. Okay? Well, that's one thing that they're going to ask us today. They're simply going to give us a point. They're going to say, well, what if I give you the point 1, negative 4? They're going to say, is this a solution? And the way we prove it is just to take those coordinates and we plug them into the problem. So if they're telling me that 1 is x and my y is negative 4, well, again, the equation is y equals x minus 3. We're plugging it in to see if it works, where x is 1, so it becomes 1 minus 3, and y is negative 4, and we're trying to see if it's true. So 1 minus 3 gives me negative 2. This one ends up not being true, so we would say this is not a solution to the problem. Okay? So what we're doing today with equations in two variables is we're trying to find an x and a y that go together as a partner that is a solution to the problem. Alright, here's example 1 for you guys. Tell whether the ordered pair is a solution of the equation. So I give you the equation, y equals negative 4x plus 9, and then they're asking you, this ordered pair, is it a solution or is it not a solution? So I'm going to let you guys pause the video and go ahead and see if it works. Okay, we're back. So hopefully what you did here is you realize, well, this first 3 is my x coordinate, the negative 3 is my y coordinate, so we plug them in. Y is negative 3. This becomes negative 4 times x, but I know x is 3, and then we're going to add 9. We're going to simplify what we can. Negative 4 times 3 is negative 12. I add 9 to that. Well, negative 12 plus 9 is negative 3. So negative 3 equals negative 3. Yes, that works. So we say yes, it is a solution. 3, it's not the only solution, but it's one of the solutions. Alright, so that's one thing that they're going to ask us today. Just find out if that point actually is a solution or not. Next thing that they're going to do is they're going to want us to graph some of these. So I got 3 of them here that we're going to work on. Actually 4, because part C has 2 of them. It says graph the equation. Tell whether the equation is a function. Okay, when we're graphing these, we've kind of done these already. What we're going to start to do is make our input-output table, or our XY table. Alright, we're going to choose some numbers for x. I'm going to make you choose 3 numbers. They can be any numbers that you want them to be. You can pick 0, 1, and 2 like I just did. You can pick negative 1, 0, 1. My suggestion is try to pick easy numbers so that when you plug it into the equation, you get easy answers. Okay? So I'm going to scroll to the next page and then we're going to do part A. So part A said y equals 2x plus 3. So step number 1 is we're going to make our table, our xy table. Okay, we're going to choose 3 numbers for x. I'm going to choose, like I did on the previous page, 0, 1, and 2. Now, just one at a time, I put them in my problem. So I start with the 0. This then becomes 2 times 0 minus 3. Well, 2 times 0 is 0. 0 minus 3 gives me negative 3. Okay, now I put the 1 in. So that's 2 times 1 minus 3. Well, 2 times 1 is 2. 2 minus 3 is negative 1. And then we got to put the 2 in. So that becomes 2 times 2, which is 4, minus 3, which ends up giving me 1. Okay? So my range is negative 3, 1, and 1. Now what we're going to do is simply take these things, alright, this 0 and the negative 3, because those are answers together, and I'm going to write that as an ordered pair, 0, negative 3. I'm going to take the 1 and the negative 1, because those two things go together. When x is 1, y was negative 1. And then finally, the last pair is 2, 1. I'm going to write them as ordered pairs, and now what we're going to do is we're going to graph these things. So, my first point is 0, negative 3, so that's 0 left and right, down 1, 2, 3, at negative 3. Alright, 1 comma negative 1 is 1 to the right, down 1. and then 2, 1 is 2 to the right, up 1. Now, this is kind of hard for me to draw on the iPad here, but what you need to do is make as straight of a line as possible. So when you're graphing your lines, you are going to use a ruler. And what you're going to do is put your ruler on these 3 points now, and you are going to draw a nice straight line through them using your ruler. Extend your arrow out in each direction. You want to stretch that arrow out. All right, so the top of the arrow goes at least as tall as the top of your graph, and the bottom line goes to the bottom of your graph. Make it nice and straight, and put arrows on the ends. Now, this arrow, this line, represents every single answer that works in this problem. Okay, if I pick any point on the line, its coordinates, x and y, for that point, if I plug it into the problem, they will all work. Okay, and that's the whole point of doing this. All right. This one here, y equals 3 over 2 x plus 1. So 3 halves x plus 1. Well, when you have a fraction here that's being multiplied by your x, okay, when you have that, there's a little trick. And I'm going to show you the trick, and then I'm going to turn you loose on it. So when I make my xy table here, again, we get to pick any numbers for x that we want. I suggest that we pick 0. 0 is always a great one, because when I plug 0 in place of here, this then becomes 3 over 2 times 0 plus 1. Well, 3 halves times 0 is 0. 0 plus 1 is 1. All right, so you're able to get 1 right away. Okay. The next thing I want to point out is with your other numbers. All right. I know that when I take this 3 over 2 times the x, okay, what I want is I want to get rid of that fraction. So watch what I do. Whatever this denominator is, in this case the denominator is 2, I want to pick multiples of that number. So numbers like 2, 4, 6, maybe even negatives. Negative 2, negative 4. Because when I do that, watch what happens. If I pick 2 for my next x, when I put it in place of here, 2 is a whole number, and I write it 2 over 1. Okay? But watch what happens. The 2's cancel out. That's the whole reason why I want to pick multiples of that denominator, so that I get rid of the fraction. Because now this becomes, okay, 3 times 1 is 1, over 1 times 1, which is 1. So that becomes 3 plus 1, which gives me 4 when I do that. Okay? Again, we got to do one more here. Y equals 3 halves x plus 1. Well, I can't choose 2 again. I got to pick another multiple. So let's choose 4. This then becomes 3 over 2 times 4, which I'll write as 4 over 1 plus 1. Well, the 2 and the 4 cancel, giving me 1 and 2. 3 times 2 is 6, plus the 1 gives me 7. So when I chose 4, I got 7 as my answer. So again, when you have fractions, we can get rid of those fractions by picking 0, of course, but then also multiples of what the denominator is. If the denominator was a 3, I'd pick numbers like 3 and 6. All right, or even negative 3 if you're good with your negatives. All right, let's graph this. So I get my graph paper up here. All right, and we go from here. The first point is 0, 1, so 0 left and right. Up, I'll change my color here. Let's do blue. Up 1. There's my first point. Second one is 2, 4. 2 to the right, up 1, 2, 3, 4. Okay, my final one is 4, 7. So 1, 2, 3, 4 to the right, up 1, 2, 3, 4, 5, 6, 7. And I put my point there. Again, you're going to use a ruler. I know mine's not nice and straight, but you're going to use a ruler to connect these, making a nice straight line. You extend it in each direction using the arrows on the end to say if my graph was bigger, they would keep going in each direction. All right, here are the last two that we did here. Notice these are a little different. So 2 separate problems. Y equals 1, x equals negative 4. These really should be easy ones. There's really no work involved here. What it's saying here for y, and we'll do them both on the same graph. I'll do the first one in black, okay? The y equals 1. It's saying when I make my xy table, it's saying no matter what, y is always going to be 1. It's saying y equals 1 every time. It doesn't matter what I choose for x. All right, I can pick whatever I want for x. Y never changes. And if I graph these, what ends up happening is I end up getting a vertical line right at 1. So what it's saying is, or I get a horizontal line right at 1. It's saying that this line is going to cross the y-axis right at 1. Well, here's on the y-axis, here's the number 1, and what we're going to end up doing here is getting a straight line. Actually, I wanted to do this in black so it matches here. I get a point. It's saying y equals 1, it's saying it's going to cross the y-axis right at 1. So we just get this horizontal line going straight across. Okay? We get a horizontal line going straight across. Now, the y equals negative 4. Well, it's saying it's going to cross the x-axis at negative 4. So if I go over 1, 2, 3, 4 to the left, there's negative 4 on the x-axis, and it's saying we're going to get a line that crosses it. So y equals negative 4, we're going to get a vertical line going up and down. Okay, so this is the red one. The black was this one here. And I want to go back. So there's our two graphs for these. Now, I do want to point out one thing. The question did say, now say, are these a function? Okay. Well, remember our vertical line test, all right? Our vertical line test, well, the black line passes. The y equals 1. That passes the vertical line test, so we say yes. That one is a function because there's no point when I draw a vertical line, okay, when it crosses, it will only ever cross that line in one point. Okay? This red one, however, okay, the y equals negative 4 is not a function because it has all of its points that are on top of each other. There are always going to be 2 points that are above and below each other. So that one is never going to be a function. Let's go back for a second. This was the one before. Again, I'll draw my vertical line test. If I just draw a vertical line, it's always only going to cross that line in exactly 1 point. So technically, this does pass the vertical line test. We say that this is a function. And actually, this is a special kind of a function. Because it's a perfect straight line, we would say that this is a linear function, because linear means that it's going to be a perfectly straight line, a linear function. Let's go back one more. This one, same type of thing here. Does it pass the vertical line test? Absolutely. It's only ever going to cross that red line by touching 1 point. So this is a function. It is a straight line. It is called a linear function. So we almost forgot to answer that part of the question. Okay, graph the line of the equation and then tell whether the equation is a function. Okay, so that's graphing. I got one last thing here for us today. It says write the equation in function form. Function form. What function form means is I want my answer to look like this, where y is going to be all by itself and everything else is over on the right. Okay, so it's just like solving equations before, except now I'm going to have an x in it. My goal is still the same. I want to get the y by itself. That means I have to get rid of this times negative 2. I also have to get rid of this 5x. We just have to remember the order. First thing I'm going to get rid of is the 5x. Well, that's a positive 5x, so I can get rid of that by minusing 5x. Over here, they slash kill. If I minus 5x from that side, I'm going to minus 5x from this side. What I'm left with is this negative 2y equals. Now watch how I write this. I can't combine the 6 and the negative 5x because one has an x and one doesn't. So I'm just going to leave it how it is. But I'm going to write the x first. So negative 5x plus 6 because it was a positive 6. Now my y is still not by itself. I have to get rid of this times negative 2. I get rid of a times negative 2 by dividing by negative 2. But then everything over here has to be divided by negative 2. Okay? And now I'm going to rewrite what I have. Okay? I'm left with y equals, this is negative 5x plus 6 over 2. But what we have to realize is that means everything on top is being divided by 2. That means this negative 5x is being divided by 2. And also, this 6 is being divided by 2. But 6 divided by 2 is 3. So there is my final answer. I'm taking that 2 and separating it onto both terms over there. All right, I've got a part B for you here that I want you guys to try on your own, and then we're going to be done for today. Okay, final problem here. I'll write it in blue. Part B is for you. We're going to try to write 6x minus 3y equals negative 9, and I would like you to write that in function form. So go ahead and pause the video. Okay, you're back. Again, our goal is to get this y all by itself. It means I have to get rid of the times negative 3 by dividing by negative 3, and I've got to get rid of this 6x by subtracting 6x. So let's take care of the 6x first. Get rid of the 6x by minusing 6x so it goes away. And then I minus 6x over here. Let's rewrite what I have left. Negative 3y equals. I'm going to write this negative 6x first, and then it's a negative 9, so I write minus 9. Okay, still got to get the y by itself, so let's divide by negative 3. So they go away. But then everything over here has to be divided by negative 3. So it becomes y equals. And if you want to separate this right away, Negative 6x is going to be divided by negative 3. All right, and then I also have the minus 9 over negative 3. All right, and then all you're really going to do is reduce. All right, I have a negative 6 and a negative 3. Negative divided by negative is a positive. 6 over 3 is 2 over 1. So that ends up becoming positive 2x. And this is a I'm going to put the negative with the 9. It's a negative 9 divided by negative 3, which is a positive 3. And there's my answer in function form. Okay, that's our lesson for today.